Good day, everyone. This is Kenny Babalola from Demographic Research and Consultancy Company, DRACO. Today we will look at the rudiments of data analysis. First of all, we will define data analysis. Data analysis is a process of inspecting data, cleansing and transforming the data. It also models the data to give us useful conclusions to support our decision making. Data analysis also processes raw data to bring out good results. Also, there are terms we have to know in data analysis. The first one is variables. A variable is a quantity that changes or varies. Also, we have quantitative variable. Quantitative variable is measured on a numeric or quantitative scale. It depends, it can be measured and it also deals with numeric value. For instance, we can consider the worker's salary of a civil servant. Now, the salary could vary from 8,000 naira, 3,000 naira, it depends. It's just that this kind of variable, as it deals with numeric value. Also, qualitative variables. They are variables that are not numerical. They can't be measured. It's an expressive variable. We can look at the rates or the state of coronavirus presently in Oyo State. This kind of variable is a qualitative variable. We have the dependence variable. The dependence variable is being tested and measured in an experiment, and it is dependent on the independent variable. The independent variable is a variable whose variation does not depend on that of another. And differences between this dependent and independent is that dependent depends on the independent, while the independent does not depend on any other variable. For instance, if we want to consider the civil servant salary, and we could say that the civil servant salary is determined by the educational level. Now, the civil servant salary is a dependent variable because it's dependent on the educational level, while the educational level is the independent variable. So the dependent variable depends on independence to give us the outcome. Also, dichotomous variable. Dichotomous variable consists of two categories, like two distinct values or categories. For instance, looking at the gender, we have both male and female. There are two distinct categories of values. Also, HIV status. HIV status could be either negative or positive. These are examples of dichotomous variable. Categorical variables. Categorical variables has two or more categories. That is, they are limited fixed numbers. They are assigned to a particular group. So, for instance, looking at the gender again, we have the male and female. The male and female are actually under the category of gender or the gender group. Also, residence. Some people live in the urban or the rural area. Income level also. Some actually earn a low income while some earn higher incomes. So those are categorical variables. Continuous variables. These continuous variables are uncountable sets of variables. It takes a limited number from the lowest to the highest, and it could be vice versa. So we can under the category continuous variable, we can consider the time to get to a particular place, which can be calculated and can be seen as maybe 2 hours, 5 hours, 10 hours, it depends. Or maybe you want to calculate the distance between two places. It could be in kilometers, 5 kilometers, 4.5, and all that. We have the discrete variables. These discrete variables are finite numbers. They are countable. They take all numbers, and they are definite. So, for instance, considering the number of students in a class, it could be 30, it could be 50, and it doesn't take decimal, unlike continuous variable. It's because we can't have like 10.5 students. That's not visible. Also, we have random variables. A random variable outcome is a numerical outcome. So, a random variable If it is a variable whose outcome is a numerical outcome of a random phenomenon, the outlier is a data value which is too extreme to belong in the distribution of interest. Measurements of variables. There are various ways you can measure your variables. One is a nominal variable or nominal scale. Nominal variable is determined by categories. Now, a nominal variable, a category is not greater than the other. Let's consider color. Color, for instance, in the categories of color, we have red, blue, green. They vary, but these colors are not greater than the other. Red is not greater than blue. Also, gender. The fact that you are a male does not make you greater than the female, and also otherwise. We also have ordinal variable or scale. In ordinal variable, there's an order. We have greater than and we have less than. We have grades. It could be ABC, it could be the other way around. And we can consider the levels of academics too, educational levels, where we have nursery levels, we have the primary, we have secondary, we have tertiary levels of education. We can see that it has an order, and that's an example of ordinal variable. We have the interval scale. The interval scale combines both the feature of ordinal and nominal scale. Now, the interval scales can be measured. It has an arbitrary zero. It doesn't have a real zero value or a real 0 point. That means that this a zero value does not exist in an interval scale. When we consider the body temperature of human beings, we will discover that it's a 0 degree is not visible when checking the body temperature. Also, the ratio scale. The ratio scale combines nominal and ordinal, and there is a real 0 point. In the ratio scale, we have a real 0 point. When you look at your weights, when we check distance, there's always a real 0 point. Also, we have forms of statistics. Forms of statistics, we have different types of forms. The first one is descriptive statistics. The descriptive statistics aims at summarizing data sets, and it includes, the example of descriptive statistics includes mean, median, mode, standard deviation, variance, graphs, and charts. The mean is best used when you have a continuous data set that are normally distributed, and the mean is usually affected by outliers. The median is less affected by outliers and skewed data, and the mode is used for categorical and numeric data. It should be noted that the data is normally distributed when the mean, median, mode have close figures. Also, we have inferential statistics. This inferential statistics allows to infer, predict, or make generalizations about a data set or population. There are two types of inferential statistics. We have estimating parameters, we have the hypothesis testing. Examples of inferential statistics include t-test, ANOVA, regression, etc. Levels of analysis. There are three major levels of analysis. We have the univariate analysis, bivariate analysis, and multivariate analysis. Univariate analysis implies that a single variable is analyzed, while in bivariate analysis, two variables are analyzed. Multivariate analysis implies that three or more variables are analyzed. Graphical illustrations. In data analysis, there are graphical illustrations such as bar charts, pie charts, histogram, line graph. A bar chart is used to show comparisons between discrete categories of data, while the pie chart displays data in circular form. Histogram is used for continuous numerical variable. Then the line graph is used to show trends or compare changes over the same period of time for more than one group. There are statistical tools in data analysis, and these tools include chi-square. Chi-square is used for testing relationships or association between categorical variables. We have the t-test. The t-test is used to compare the means of two given samples that are normally distributed. There are three types of t-tests. These include paired t-tests, independent t-tests, and one sample t-test. Correlation. Correlation measures the strength of association between two variables and the direction of the relationship. There are also three types of correlation. We have the product moment correlation, Spearman rank correlation, Kendall rank correlation. Assumption on each statistical tool depends on the type of statistical tool. That is the correlation, regression, t-test, etc. Thank you so much for listening. Do you have any question? You can drop it or send it to the numbers below, or you can forward it to the website info@dracoresearch.com. You can also contact us on our Instagram, Facebook, and Twitter page at dracoresearch.com. Thank you.